Good afternoon, folks. This is our last stream of the semester. So I'll be going over the final project. I'm going over the last lesson regarding hashing passwords. And I think that's it. So this final project is your final exam. Get the chat open here. All right. So let's start with finishing out the material, and then we'll go over the project. And I believe we finished this one. The one thing we didn't look at is okay. Here it says add a we'll finish this up first from the last one. Add a column to the user class representing its relationship to the movie class. We did do that. So remember, we reformatted everything to follow a model closer to the MVC model. And so our classes that we use for our object relational mapper SQL alchemy, we're storing those in models.py. So it says add a column to the user class representing its relationship to the movie class. So here we have let me look at that again. Okay, I think they got that backwards. We added a column to the movie table that shows which user entered that movie. Okay. And then it says add a property. So this is just saying add a property to the movie class that holds the ID of the owner. Okay, so that's what we did. So there was specifically a way to pull out, well, we can just look at 9 and then I won't have to walk you through it. Okay. All right, so I need to commit my changes to the local repository before I change branches. Okay, now I can check out Studio 9. Okay, and we should be able to see in here. Close all of this stuff. I think there's a close all. Close folder. Okay. And then we'll do code dot. So these are the new files. remember the first thing we got to do is fix the database connection string. So your database username that you created for this app, the password, the port, and the name of the database. Okay, so that's all there. And as always, I gotta turn on word wrap. Alright, so now we can connect to the database. Let's check models and see how they did this. So, in a database, we're worried about data redundancy. And in programming, we're not so worried about data redundancy in memory. Okay, so in the database, we don't want to store inside the table for users every movie that they've entered, right? Because that would create a lot of extra columns. It would just be unfeasible. So what we did was we added an ID for the user ID inside of the movie class. So when we store a record there, I might have to rename my columns here. Oops. So if you are using the studio and you need to update your database using whatever classes they created, because the ones I went with are things I thought of. So we have to go through this process of import, or no, it's from main, import db class, our classes, user and movie. Alright, and then we do db dot, db dot drop underscore all. Okay, and now if we look in the database and we do describe movie, there is no movie table anymore. There is only this table for some reason. I think I created that just to test out something before that I forgot about. So let's get rid of that. So we can drop table. Cool. All right, and now there are no tables in this database. So we got rid of all the tables by doing drop all. Okay. Let me clear this. Okay, let's quit out of here. Or no. Let's try running that drop all again. Okay, now let's check the database to make sure there's no tables in there. Oops. Do show tables. No tables. Okay, so now we're ready to use the classes that we added in here, user and movie, with all of this column set up. We can create those empty tables. So we need to go back into Python and do db.create all, and we can see from those classes it created for the user an ID, email, and password. But in our user class, we also have this movies property that we created, but that's not reflected as a column in the database. Okay. And if we look at creating the movie table, this is looking at the SQL. We have these columns: ID, name, watched, rating, and owner ID. So we have ID, name, watched, rating, owner ID. All right. So this is saying, you know, ID is the primary key. Here, for the field of watched, it needs to be value 0 or 1, because you either didn't watch it or you did. And then right here's our foreign key constraint that prevents us from deleting a user if they still have movies in the database, and it prevents us from adding a movie for a user that doesn't exist. And so we're saying the ID here, I'm sorry, owner ID here relates back to ID in this table. So if you've taken or were in the database class, this would be an entity relationship diagram with two entities that have a one-to-many relationship. One user can have many movies, but each movie only ties back to one user. So anyway, we're done with Python at this point. And we can see now, if we do show tables, we have movie and user. So we can describe movie, shows us the fields, the data types, their properties. So let's go back to this property here. Movies equals db.relationship. So remember, the db is our SQL alchemy object, and so we're using this relationship function or method to tie the movie class with a reference to the values stored in movie. So what this does is, if we pull a user record, it will also grab all the movie records that have the owner ID stored in the movie table. All right, so let's see if they're actually using that in here yet. So main, up here where they're getting the get current watch list. Okay. They're saying, out of the movie table, grab all the records that have watched set to false, and then have an owner ID of the person who's currently logged in. All right, so they're not using it there, but where they are using it is inside of the route where they're printing it out. Right. Okay, so we are opening, so when you go to the index, Interesting that they put this function just out here, but they're calling, I guess they created a function here that checks who's logged in. And it's a good idea that they're doing this here, so every time you are pulling the information, it's checking to make sure the person is logged in by pulling the email address from the user session variable, which we are setting when we log in. Right. This is kind of a review over what we looked at last time. So here we have login session user equals user.email. I'm grabbing that from the user table. After we check whether the password entered is correct. Okay, anyway, so we're printing out this list in here. So we are rendering the edit.html template, and we're passing in that list of movies from get current watch list. So I'm wondering if they're even using that. They set it up, but I don't know if they're actually using it. Let's see if they talk about it in the actual studio. Da-da-da. Okay, we refactored. Okay, we did all that. So yeah, I'm not sure why they're using that here. Maybe in Studio 9 they use it. And so here in Studio 9, the important thing to take away from this is how to hash passwords so we aren't storing them as plain text. So that way, if someone gets the database information, it doesn't just tell them everyone's password. It'll at least be hashed so that it would be very difficult to figure it out. So it says passwords should be hashed when creating a new user account. Okay, so if someone gets into the database through the difficult process of breaking in or hacking, or the much easier way of social engineering, where you just pay someone that works there to get it for you, or you blackmail them to get it, or you trick them. Anyway, you need to set it up so that if that happens, it's harder for people to figure out the passwords. So here they're using SHA-256 to hash the password. Let's see what is actually the best practice right now. Because if you're in an interview, it'll be much more impressive if you can. I think I can put this in Dropbox. I didn't want to lose this. Yeah, it is. I'll just throw it in here for now. I'll sort it out later. Script. to ERD. Oh yeah, and I want to look at this SQL alchemy backref thing. See why they were doing that. Oh yeah, and we're going to look up best Python password hash. Excuse me. So let's look. Here's a Stack Overflow. It is from well, I guess this was asked 8 years ago, and here is the answer from well, they edited it on July 6, 2019. All right. This question. How do you reverse it to get the password back? That's the point of hashing a password, is that it's not easily reversible. It's nearly impossible to reverse. Okay. Whoops. Giving me some lag here. Let me digest how to use this and then we'll go over it. So remember, when you're using Stack Overflow, the top thing here is going to be the question that's being asked. This is not a good answer to use because the person is having a problem with this. Okay. So you can read this part to figure out if the problem they're having relates to the problem you're having. Then to get the answer, you look down you look through the list of answers. Usually it's the first one with a check mark. The check mark means the person that asked the question was able to use this solution to solve the problem. All right. And so in Python, this is from July 6th of 2019. There may be something more current, but that's not too bad. A year and a half ago. So they're using these packages, hashlib, and UUID. And so what this does is it generates some value here and stores it in a variable, and this is called, what they're going to be using this for is to salt the hash. So to generate the actual hashed password, we'll call hash library.sha512, and so you can tell the age of this because they are using no, we're not talking about get it done. We are talking about this. They're using the SHA-256. Okay, so I guess we should talk about hashing passwords first. So why not demonstrate it in Replit? And I'm not going to use the VM for this. We'll come back. All right, so okay. All right, let's find one here that they're using. Using SHA-256 in this example, and this is from May of 2019, so the other one was more recent. All right, so we need these. And so let's say our password is Bob. Oops. Just output all the information so we can see. And the hashed password. Okay, let's see what it's mad about. Opening here, got my comma. All right. Hash password. Unicode objects must be encoded before hashing. Okay. Let's figure out how to solve that. Back to Stack Overflow again. Here's the question. Let's look at the answer. Okay, so we need to encode it with UTF-8. Let's try that. That's what we need for the password. All right, next is can't concatenate string to bytes on line 7. Okay, So I think we have to do something else with this. Probably have to so what this is telling me is inside of this function, one of these functions, they're adding, oh, I guess this, because salt is a byte value. Let's try doing this. Dot x. Nope. Okay. So you, for something like this, you always need to be constantly understanding the where in the war security is when you're working on using anything with passwords. If you don't keep it up to date, you're going to run into issues. All right. String code. So yeah, they're doing SHA-256 here. Okay. Password. The password is just a string. There. Goes in as two strings. Here we go. Let's just search the error. Okay, Python 3, okay. Two bytes. Well, let's try this. What was the error we had before? So we try to use this. Well, let's look up what the function needs. It's important to understand what you're doing, right? All right, so we want to see hash dot SHA-512. So this is a constructor. What values does it take? Can now feed this object with bytes like object using the update method. Okay, let's try this. Nope. Okay. Looks like they're just putting B in front of it, so try that. I know that's not going to work. Okay. Let's see what this looks like. Okay. So it does that for me. There. So, you know, using what is in the directions is using something out of date. So it's worth figuring this out. What if I have to do it this way? Nope. Well. Oh, here we go. Some examples. Okay. Oh, it's hex digest. Derp. Because it looks like they're getting that as hex already there. So maybe we don't need to do this here if we do it there. These are some good examples of what's happening, though. So here are some examples of hashed passwords. They're using it here. Let's see if we can look at this. It's funny, this is actually a Flask thing. Okay. So we have start, stop, restart. Okay. So if whatever they type in, when stripped and ran through hex digest and hashed using SHA-512, matches what we have stored in the database, which is here, then it then it should it'll print true or false. Now where are we doing this? Okay, they're adding these together. I wonder if that result we had is missing a step. So let's look at that. Hashing Python 3. Hashing password Python 3. Oh, here's a Flask tutorial. Do we have the code? Oh yeah, we want to do it with salt though. We want some salty hashes. Okay. Replace hex with bytes. Let's see what this returns, because I'm not familiar with what this function is. Oops. Let's see what that returns without that. Int salt. Alright, so that's a string. And that's what we have for the salt. And then if we do that, here's the hex value. Let's try it as bytes. So if we do this as dot hex, and saying you can't get a hex value from a string, let's try it. Let's try print password x. Okay, so you can't do that. You do this though. It does print it out here. Built-in method hex, a bytes object. So that's the object. So that's what this is printing out. Okay. We printed out this already, right? Yeah, we did. Okay. So, and then this didn't work, right? Oh, that did work. Okay. So we have those, and but it's saying if we do this. Alright, so it says salt is a string. That's not going to work because that's not a string. And then if we tried to use it just as a string, it's mad because it has to be encoded. So let's try encode UTF-8. Okay. That makes it bytes anyway. We can't hex that. Built-in method. Oh, we'll probably have to do this then. There we go. And now it says Unicode objects must be encoded before hashing. So we'll get this working here. Alright, we got it. It was just trying to figure out what goes where for this new thing that I'm not familiar with. I understand what it's doing in the what it needs to do this, but now that we got the numbers, we can take a look. All right. So the one thing I'm curious about though is how to use salt hashing. Just want to make sure I understand this. All right, so all right. So without salting, your password is weaker. Okay. All right. Okay. So. do we do a different salt? Okay. Okay. We store this. This is what I was wondering about. We store the salt in clear text with the hash text in our database. Okay. Okay, generating the salt. All right, da-da-da. So you don't want your salt to be able to be reverse engineered. Secure random. Okay. Okay. Oh, what's this? Decrypt. Do we have decrypt in Python? It's funny. Oh, here we go. July 6, 2020. That's even better. So to use this, we need to have the Decrypt library, but let's see what the example looks like. So you generate salt, put them together. All right, here we go. This is much simpler. There we go. And it probably doesn't have access to Decrypt. So it's going to install it. On Replit, it's nice, it'll install it. Okay, so we have the bytes for the salt here. And it looks like they are just sticking the salt right on the front of the encrypted password. And which encryption does it use by default? Ooh. It took more. Okay, it took 4 seconds. Let's try that. Let's really make it well encrypted. And then we'll talk about how this works. I've got a very simple example of the old way to do it. That'll help you understand what we're doing here. Okay, so it takes a lot longer to generate. And again, it's just sticking the salt at the beginning. But here's the thing. Let's say we have user 1 is Bob and user 2 is Sally. of course, when we're looking at this, we're going to be taking this information in from the user when they register. Alright, so if your password is secret12, we'll keep Bob's password as that. We'll change Sally's password to Apple Orange Secret Santa Christmas. Apple Orange Secret Santa Christmas. It's a very long password. Unfortunately, it doesn't follow the rules of including a symbol and a number and a capital letter. But it's pretty easy to remember. It's just words, just a phrase. You can pick any phrase. Just don't pick something that's related, can be easily related back to you. Okay. But that you can remember. And then, so because we're doing 16 rounds of salting, it takes it a long time to do it, which means it's going to take it even longer to undo it. Let's just make sure about that. Okay, so this Decrypt is what we want to use. I'm going to go ahead and post this to you. So, because this is what I'm going to expect you to use in blogs. And since we're here, we'll go ahead and talk about, I wanted to talk about the final assignment. So you'll notice it's worth a lot more points than the other ones, double to be exact. Okay. So you just follow the directions, but keeping this in mind. The following bonus mission is required to receive full credit. So you lose half the points if you don't include this because it's so important. Use the following technique. Decrypt. Okay. Part 2, you will receive 1,000 points extra credit if you complete the following bonus mission. That's a lot of extra credit. And so these are in the directions, but you'll add something called Pagination or Pagination. I guess I'll just call it Pagination. That sounds less ridiculous. And so if you follow the rules for setting up blogs, if you have 1,000 blog posts, the screen will generate all 1,000 on the same page, and that'll create a really long page, and you don't want to do that, so you can use Pagination to grab all 1,000, but then it only shows so many on the page, and you can switch to the next page. It's a really good idea to understand, but I'm not going to require it in this class, so that's just a bunch of extra credit. They talk about some links that help you figure it out. Being able to figure out things on your own is actually the most important part of this entire class. Alright, I talk a lot in here about how important it is that you double check your work. So once you get it work, so you need to create the repository, clone that, then do your project in that folder, and then you need to push that to the repository. Okay? After you do that, you should go create another folder on your VM. Inside of that folder, clone the project from GitHub and make sure it works. Because when I grade it, I'm going to clone it. And even if the version that you made works on your VM, I'm looking at the version on GitHub. So you have to make sure that you have that up to date. So I have a little checklist here of what you should do. Because the due date is so close to the end of the semester, because I want to give you guys the most amount of time, if you turn it in late, I just won't have time to grade it, so it'll be a 0. So don't put this off. You know how lenient I can be, but I have no control over when final grades are due, so I can't give you any more time. Since this is the final project and is the way I test your abilities, if you can't complete this project, that means you didn't put enough work in the course, and so you'll have to take it again, or maybe rethink your career path. I won't be able to help you figure out the code. The most help I'll give you is clarifying the directions. So don't hesitate to ask me. If you want to ask me something but you're not sure if you're allowed, that means I'll tell you. If you ask me something and I can't give you information on that, then I'll tell you. But I'll be as helpful as I can. This is the test. The practical exam. At this point, you should be able to do everything included in this by yourself. Okay. So let's go back to this hashing example. We're going to take the 16 rounds out because it's going to take too long to do that. All right, so we'll do print user1 and print user2. All right, and we'll put some space between them here. So we can see, and you saw that it took a little bit of time in between. That's because this hashing takes a long time, and that's good because the easiest way to take a hash and figure out what someone's password is to try every combination. So let's take a look at what we have. So Bob's salt generated like this. And let's look at it with and without the salt. Knowing security, at least the basics, gives you a huge advantage as a developer. And I wish I could say that it was basically required, but it's not. But it gives you a huge edge over other developers that may not understand it. All right. So we'll do hash salt hash with salt. I guess you have to use salt with Decrypt. Is there one? That doesn't use salt. Probably not. Ah. All right, so we can't actually do this. So we'll just get rid of that, which is good because you want to use salts, and it'll make sense. I have a really good example of what happens if you don't use salts in your password hashes. Okay, so here we have the salt. So we would store this in a. So in the user table, we need to add two columns: one for the salt, one for the hash with salt. Whoops, and I was wondering why they had the same one. This is what happens when you change the variable names without paying attention. Okay. So here, let's figure out, I'm trying to understand this so I can explain it the best. So let's print salt len. I want to see if these salts are the same length. Oh, whoops, we're out a parentheses. Alright, so they are the same length, 29 characters, and it doesn't matter how many passes we go. Oh, what was it, set equals 3 or something? What was it? Rounds equals. Decrypt dot gensalt rounds equals 3. What if it has to be a power of 2? It might have to be a power of 2. Okay. So, okay, this will, let's see if it can do 2, because I don't want to do any long ones if I don't have to. No, maybe it's a power of 4. It can do 4, it can do 8. So, I don't know how this is decided. Oh, I bet it's has something to do with bytes. Anyway, we don't have to go into the algorithm, but we'll do this one at 4. And let's do it again. At 8. I want to illustrate what this is doing and also figure it out myself from what I know and what you guys need to know. Okay. I only need one user now for this. Let's get rid of that. And we don't need this anymore. We need this here. And we need it. Oh, we need this again before this. Oops, not that. This. All right, so if our password is Bob for Bob, all right, so what we're doing is we are equals that, and then we're taking that and using password with the salt there. Okay, and we're changing it there. Okay, so for the first salt, it generated this, and so that also just gets added on the front of the actual hashed password, which I guess, is it always just going to be 29 characters? Let's do a little message in here. Length salt, len of salt. Oh, whoops. Yeah, we want that to be here now. All right. Yeah. So with 2 examples, and if we keep running it, you know, one's doing 4 rounds, one doing 8, it looks like it's always 29, but I'm wondering if, since it's including these, because it's stored as bytes, it's actually just 26 characters. So why that is, there might be a mathematical or a computer reason for that. I don't know off the top of my head, but I just wanted to make sure. Okay, anyway, if we do 4 rounds of salt on our password, generates this this salt up here. Okay, and then it applies that here at the beginning concatenates that on, but using the hash function to combine the salt with the password before it gets hashed affects how this gets encoded. So when we did 4 rounds of salt, gave us this, and because that's in there, the password Bob gets stored as this string. Okay, and then if we do it with 8 rounds, it's a different salt, and that generated this. And so I guess you probably don't understand why it's important that these are different, but they're created using the same password. So let me bring up that other example, because now I think I understand this. So I'll show you an example that I like to use in the Python class. And I think I fixed this so that so it should say, what is the password? So this was on password, and then what are we using that? I don't know why that's there. Okay. It's either this one or the other one. Might be this one. Well, here's where you get the encoded. Okay. So this one, they're using hashlib SHA-256. So for this one, you just type in a password, and then it runs it through this hash. And so here's an important thing. Here is, we typed in Bob, here's the password. Oops. Or here's the hashed password value, which is what you would store in the database. All right, and then if we do it again with Bob, here's the value. Okay. And what's important to see here is this is the same value. So no matter what you type in, you're going to get the same value for this. Okay. So if a website or any system is using this to hash their passwords, that means you can create something called a brute force. So if you get the database of hashed passwords, you can write a brute force program like this one. Or, nope, not this one. Let's keep this over here. I should just put these in one file so that I don't have to keep. Also, I named them backwards for whatever reason. All right, so I can write a brute forcer, and I know they used, somehow I know they used SHA-256, and so I can just start generating, just like you would, you know, if you had a combination lock. You know the combination is 3 numbers, so you can just, if you really care, you can try every combination of numbers, and eventually you'll open it, right? So here we can just try every combination of characters until we figure it out. So what is the hash? So remember our password was Bob, and we generated the hash in the other program. So we can paste that in here, and then we say, okay, go. And so here, what's happening here, and let's make it more easily readable. And this takes a long time, so Replit likes to crash while doing it. If that happens, you can just refresh. We'll start fresh here. Alright, so what is the hash? So we want to find the password for whatever user is in this record in the database. So we'll put in the hash. And then we will look at the output. Can I get rid of this? I think that's as close as I can get. So we have trying, so it was trying every combination of 1-letter passwords, every combination of 2, and then it got to 3. Remember our password was Bob, so BAW, BAX, it's trying every one at a time, and for every one it's running it through the SHA-256 password hash, and it's generating that hash and comparing it to the one we entered to see if that's the password. And so when it gets down to BOB, it says, okay, BOB is the password because the hash generated from that matches the hash that we pulled out of the database. So now you saw how fast that worked with a 3-letter password. This is just a demonstration of why longer passwords are better for, at least for brute forcing. All right, so what do we have for that other one? Apple, orange, Santa, Christmas. All right, here's the hash for that. We go over to the brute forcer. Let's clear the console. Now we run it, put in the hash, and for the sake of time, well, we'll just let it run and see what happens. So we can kind of see what's going on down here. Right now we're in 3-letter passwords. There we go. You can see it a lot better. So it's J, K, L. So you can see it takes, a second or two for each letter. I guess we can zoom in here. And normally, you wouldn't be printing this out. I'm printing it out just for demonstration purposes and to understand how one way your data is trying to be correct. And now, the reason people do it this way is because the hash function takes a password and it creates this string of values or characters. It's very difficult to reverse engineer the original value out of this, that it's actually faster to try to generate it this way. So now I'm in the 4-letter passwords, and so it's going to, and we're only in B of the 4-letter passwords. And you can see this is going to take forever. And it will take longer for every character, exponentially. So you're safer if you have a longer password against brute forcing, because you have to try every combination of whatever exists. And so this is only looking for passwords that use all lowercase characters, A through Z, but a lot of places require you to include at least one uppercase letter, one number, and one symbol. So I only have to check 26 characters in each position. If you have that rule, you have to check 26 for lowercase, 26 for uppercase, 10 for the numbers 0 through 9, and how many ever symbols there are. And so that just also adds a lot more work. Now here's the thing, if the computer I was using was more powerful, it could crank through these a lot faster. And so eventually it'll be a joke to be able to get to figure out what every password would be using this, because you could just generate them really quickly, once computers are that fast. So let's stop that. And I'll try to remember to update this later. So we will demonstrate how to use this. And so why is this different? Well, when we use this generate salt, it uses an algorithm to generate a random string of characters. Based on whatever, you can look up what the meaning of pseudo-random is, and that's the ability, that's what a computer can generate, is a pseudo-random number, which means it has to be based on some sort of real value. If you know what that is, then it's easier to solve it, but you can make it complicated enough that it's not easy to solve it. So I think if you set it to multiple rounds, what it does is on the next round, it basically runs itself through the salt generator 4 times. That's why it takes so long if you increase the rounds. And then, so it mixes it up. And so once we get to the actual hashing down here, we combine that randomly generated salt with whatever they put in as their password, and then we hash that. Okay, so that brute force tool I was using, I would have to know what the salt is, which that would be stored in the database, same place the password is. I would need to know what else would I need to know? I would need to know the salt. I would need to know the password. And so here's the thing. Because we're doing it this way, and remember I talked about how when we're using different salts here, and I wonder if we do 4 for both of them, if they'll still end up different, because it's supposed to be random. All right, it got mad because I changed something. Okay. So even if I use the same number of rounds, it's still going to be different because it's random. Pseudo-random, sorry. All right. So even if 2 users have the same if 2 users have the same password when I was using SHA-256, once I figure out one person's password, I know everyone who has that same password. I know everyone's password that uses that password. In this case, if I want to figure out a password, I have to specifically target one number at a time and try to figure that out. So it just adds more time, complexity to the search space for that password. And so you see how easy it is to use. You just generate the salt, use it in the hash, and then you have to keep the salt value and the hash value, and as long as you have those, you can test when someone tries to log in if whatever they type generates the same answer from the salt and the hash. So let's only generate one here. Okay, so we have the hash with salt, and we don't need this anymore. I was just checking if those were the same length. All right. And so let's make a little test here. We'll do so we'll set value. We'll make it -1. So value equals 0. That'll get it into the while loop, and we'll just ask them for their username and password and see if they can log in based on what their username and password is. So we can go username equals input user name password equals. At no point in the process, other than the memory of the web server, which is gone after it gets cleared, does the password that someone enters ever get stored. It never gets stored on any hard permanent storage. You don't want to do that because that's a huge security risk. Alright, so we'll take those from the person, and we know, so we'll have the salt and the hash stored in the database. So if they enter their username and password, if we'll call this toCheck equals we'll take in their password, the password they typed, apply the salt that we have for that user, and then we say if toCheck equals salt hashed login successful. If it doesn't find a match, we say incorrect password. And then to get the while loop to stop, we'll set value equal to -1 here if they're correct, and we just won't change value if it's not. So it'll keep asking. So username, Bob. I don't know why I'm asking for the username. So the password is Bob, but let's try Apple. What does it say? Da da da. Oh, duh. Okay. We have to encode that first. Oh, Apple's not my password. Is it orange? Incorrect password. Is it Bob? Login successful. So we're never checking the password that they type in to see if that password is in the database. We're checking if the password that they typed in with the salt from that record for that username, when calculated, when generating the hash, is equal to what they typed in. So we have the, what happened here? My camera stopped working. Well, I think you can still hear me. Anyway, you're probably tired of looking at me. If you're still in this video even. Okay. So this is what you need to do for the required part in the exam. When someone registers, you'll need to generate salt for that user, store that in a column, and you will need to generate the hash using the password they typed in and the salt you generated. So you'll store two things for that user. And then when they try to log in, whatever they type in the password form, you'll pass that value into this function, and then you will have to look up the salt for that user and also apply that to the function, and then whatever this results in has to match the field, their hashed value field of that user's record. Okay, so let's look at how we would implement that now, finally. Is that clear as mud, how that works? Okay, so all we have to do is use a hashed password. And we are not going to use what they have in here because it's not up to current standards because of the reasons I just explained. Okay. We're going to use what I just showed you. And so, you know, I'll give you this so you have the working code for this. And then I'm going to do the flick list, and you can follow along if you want, or look at the code. And let's do this. Let's move this to its own desktop. There we go. Makes way more sense. I can switch between these easily. What was I doing? Oh, I was posting that link. So if you want to check out that, you can. Alright, so doing some actual work now. I don't see in here, well, I never found out where they were using that back ref thing, so after we do the stuff with encrypting the password, we'll, if I remember, we'll look into that. But we had a way where it was working anyway, so. Well, let's make sure the code is working first. Okay, so it's loaded, it says. So let's rerun it anyway so I can click the link and save time. Alright. None type object has no attribute of ID. Okay. In my main.py, line 146. Alright, so it says when we render template for the index, looks like they're missing the page. They're not redirecting us to register. So before request, oh, okay. It's, yeah, why is it giving me this error? Did it crash in here? Okay. Did I break something? So it should kick us to, well, you know what? I think it's because it's keeping the information that I had stored. It still has my session from before. So let's open an incognito window so it doesn't have any idea who I am. There we go. Alright, so there's that. It is working. If we create a new user, Bob at bob.bob, Bob should log us in and everything should work. Okay, I want to add Bob day out 32 to bobbing. And if I check that, we have it here. Let's watch it. That was great. I think by the 30-second movie from a series, you know, it's getting kind of old. So we'll go 2. I like the series, but 32 is just too much. All right. Okay, so we got data in everywhere. Let's check the database, make sure that's all good. So we want to do select star from movie, and we want to do select star from user. Alright, so movie, we have one movie in there. It was added by user 1, which is Bob. Has a 2-star rating, yada yada. But look, right here. We're storing the password in plain text. We don't want that anymore. So we can go in. We want to change that table. We want to change the structure of that table. Where do we do that? Well, we need to, since we're using an object relational mapper, SQL Alchemy, we need to go into our models and adjust it there. So models.py, in user, we need to add we're going to get rid of the password column. And we're going to call it hash. And we'll add another one called salt. Alright. And we need to import Decrypt. No. What did they call it? Okay. And we should see if we have that installed. So on the command line here, let's get out of Python. So we can do, let's just type pip. What is it called? List install packages, pip list. Do we have Decrypt in here? If we don't, we have to get it. We don't. So we can do pip install Decrypt. Alright, now if we look, we should have that package. Right there, Decrypt. Okay. So now we can access the Decrypt package, which has the functions we need to properly hash the password. So when we create the actual user object, no longer are we going to take in the password. We're going to take in a hash, and we're going to take in salt. Right, so self.hash equals hash, and self.salt equals salt. So that'll get stored in, those will get stored in the database. Alright. And then I actually have a question that I want to clear up. How to verify password with salt. Okay. Store the salt in the hash. Okay. Here it says, some hashing algorithms like Decrypt store the salt as an integral part of the hash, so you don't even need the extra column. Let's look up an example. So Flask, login, Decrypt. Okay, so they're looking, so it looks like they are using the username first to see if there are any records with that username. If they find one, they pull out We're storing the password in user entered. They show some weird variable names here. We'll fix that. Okay. Check password. Oh wait, am I looking at the problem? Yes, I'm looking at the problem. Let's look at the solution. Okay. So once you have their username, you can use that to find the hashed password and the salt to check their password. Okay. So since we're using Decrypt, like in the example, it's just putting the hash as, I believe, the first 26 characters. So let's do it that way, because I feel like that would be better. Okay. So we don't need the salt, because we'll get that from the hash function, because it's going to be stored with the password, with the hashed password. Okay, so we don't need the salt. Okay. And we'll just leave it as 120 for now, but we know how long it's going to be. They're always the same length, I believe. Okay, so we've updated that, and I think we're done updating the database. So we can go in and, well, we're done updating the classes. Now we have to update the database with those new classes. So we go through our steps of doing that. Python oh, you got to make sure it's all saved before you open Python. Okay. From main, import db user and movie. And then we do db.drop underscore all. So we do db.create all, create underscore all function. Alright, so now we can see we have the email, we have the hash, and that's all we store. And the ID, but that's auto-generated. Okay, now we can quit out of Python. So that's updated now. It's always a good idea to just follow through for practice. So if we do select star from both tables, they're empty. Oh, I guess we could describe them. Describe user. At this point we could describe it. Okay, so that's ID, email, and hash, but we don't have any values in there yet. So where are we getting people's passwords? In the registration. That's when we're creating a new user record. So we need to go to the register route. Let's find that. Oh, it's going to be /register, right? Okay. That's probably going to be the first one. There it is. Okay, so right down here, we're taking in the email, storing that in a variable, and that's fine. Storing what they typed in the password box on the form, we're storing that in a variable called password. Perfectly fine. At this point, it's just in memory, so it's not permanent storage, and will be gotten rid of eventually. But we do need to store the user's hash with the salt in the database So that way, if someone gets the database, they don't know their password, and if they get, well, so they can log in. So we got to do a lot more work right before we put the password into the database. Right here, we'll do hash that password. Okay, and we are importing models. Well, from models, we're importing user and movie. And we actually don't need to use Decrypt in here. We need to use that in our main, because that's where we'll be using those functions when we encrypt the password. Okay, and we'll just import it like that for now, because I can't remember. Well, I guess I can remember. It's all in here. Somewhere in one of these. Here it is. We're going to be using gensalt, hash pw, and that other one that was a check password. Did I keep that open? Oh yeah, that's in here. Oh, I must have closed it. But I think it was check pw. So we can do from decrypt import gensalt. Oops. We just have to put the names of the functions. Gensalt hash pw and check pw. Okay, so back down in registration. Okay, we're going to hash that password. So we need to, let's see if I can copy this out of here, because we had it already. We just need to do this and this. I think there's a setting on here. No. Proxy settings. Well, I don't know if it's a setting, but can you paste from outside? You can. Some clients let you do that, some don't. Okay. So we're going to create the salt, use the password they entered, which we stored in password. That was weird. Password with the salt. Don't forget we need to encode that for this function. So we got to do password equals. I guess we could do it. We could just do it down in here. You guys can look at the example, but just do encode UTF-8. The salt will already be encoded, and then this will return salt hash. We'll just call this hash. Okay, and so in our record for a user, we'll put the email and we'll put the hash. And I guess we'll find out if it can take that, take those bytes and store it as a string, or if it'll just crash. And then it should add that record and tell us what user is logged in. Okay, so we save everything. Save all. We will make sure the server's running. Nope, okay. turn that back on. Okay, so that's running. Go to the site. Log out. Create a new user. Because there are no users. I think, yeah, there shouldn't be any users because we just created the database new. So if we do select star from user, it should say 0. Okay, so there are no users. So we'll do bob at bob.bob, new password bob. Decrypt is not defined. Online. Oh, because of the way we imported it, we don't have to specify the package. So we can get rid of this and this. Okay, and then we should be able to insert a new user record. Try that again. Alright, it worked. Let's see what that record looks like. I wasn't sure if it was going to store that in correctly. So we'll do select, well, I have it in there, so select star from user, and there we go. We have the user's email and their ID, and then we don't have their password stored, we have the hash stored. And so the first 26 characters in here are the salt, so we'll have to pull those out, and then the rest is, well, I guess we just have to grab the salt out because that's all we'll need to run this hash password function to see if what they typed in is right. So as of right now, if I log out and try to log in again as Bob, the way it's set up now, it's just going to, I'll type the right password, but that password isn't stored in the database. And again, that is a good thing. So when we log in, we're going to have to change the way we log in to generate the hash. And compare it to what's in the database. Alright, so it's not going to be as easy to log in. So in the login route, we have two, we're checking the request method. If it's get, that means no one's logged in. If it's post, that means someone tried to log in. They typed the information and hit submit on the form. Okay, and so here we're storing the password they typed in password, and then we're getting the user. I don't know why they're calling it users. So they're doing an extra check here. Even though we set email to unique, they're still checking to make sure there's only one user with that email. That's fine, we can just leave that. So they're finding the one user here. So this gives us the information from the user record. So this has user.id, this has user.email, and this has user.hash. So what we need to do is check if user.hash is equal to the result of, I'm curious, oh, I lost that, didn't I? Oh, it was in, no, it was in here, okay. user entered I'm not sure what that function does actually. I think it does everything for us, so let's try it and see if it explodes. Okay, so we need to take what they've entered, which is, well, it's stored in password right now, and for the check PW function, we need to encode the password they typed in. Okay, and we're just using UTF-8. That's the first argument, and the second argument is the actual value in the database. And so this function should return true or false. If it's true, we will log them in. If it's false, we say you didn't log in correctly. Alright, so those two changes will allow us to use this security. Okay, and so, oops, let's try logging in. Let's go back to the login, and we'll try Bob and Bob. Well, let's try the wrong one first. Apple, see if it explodes. Unicode objects must be encoded before checking. Oh, derp. I just read it said you have to encode both the password and user.hash at this point is pulled out as a string, so we have to encode that as well. Alright. Just forgot to do that. Darn it. Okay. So now when we try to log in again, 15th time is the charm. That's my motto. It logged in. Let's log back out. Go back to login. Let's try the wrong password. Bad username or password. Okay, and so if we look at the data, well, let's create one more. So we'll call this Sally at bob.bob, and she's going to use the same password as Bob. So Bob, register. So now we can look in the database and take a look at those users. Okay. And then you tell me if there's anything about this hash and this hash that tells you that these two have the same password. What that means is someone wants to brute force it, they're going to have to take the first 26 characters and whatever and run that in, brute force that until they can figure out what the password is. And then they would have to do the same thing here again, and it would take, the same amount of time as doing it here. But they don't know it's the same until they get the answer. Things to note. Again, I will reiterate, the actual password that the user types in to log in and to register does not get stored permanently anywhere. You do not want that. You do not want that anywhere. You want to get rid of it as soon as you're done creating the hash, because that's all you need. Once you have the hash, when they type in their password, you can use it to generate a new hash. or generate a hash and just compare it to what the hash is on their account. So anyone that doesn't know their password can't get in, which that's always been the way it is. But if you lose your database, it's much harder for people to figure out what the heck the password is going to be. So I'm not 100% sure on. Let's see. There was something in here talking about something about the rounds. Okay. Oh, they have a tutorial. So I want to know more about the rounds, because I think you need to know if you use rounds. Okay. Let's see if we can just find a basic one here. Decrypt tutorial. Is that what I was looking at? Probably. Right. Decrypt rounds explained, because that didn't clear it up for me. Okay. Salt round, you mean the cost factor. The cost factor controls how much time is needed to calculate a single bcrypt hash. The higher the cost factor, the more hashing rounds are done. Increasing the cost factor by 1 doubles the necessary time. Okay. The salt is a random value and should differ for each calculation, so the result should hardly ever be the same. Okay. The calculation is done, blah, blah, blah. Yeah, here's what I want to know. Do I need to know the number of rounds when comparing a secret with a hash? Yes, the cost factor needs to be stored like the salt. Some algorithms need even more information. How much memory should be consumed? So, if we want to include rounds in there, I wonder if that gets stored. Let's go back to our example where we were hashing things. And we were doing rounds equals, let's do 8. Okay, so here, if I just do Bob, and what was the password? It was Bob. It still knows. I wonder if that is included somewhere in the salt in some way. So let's try 16, because I know that takes a long time, so that we can actually see. So if we run it again, it takes this system a number of seconds to calculate it, and then if I check, yeah, it must know how many rounds there are. It must be stored in there somewhere. See how long it took to check. So if you wanted to brute force this, it would take for every time you, on this system anyway, for every combination of characters you want to test, it's going to take that long. And so the other example, you saw how fast it went with the SHA 256 with no salt. I could check a lot really quickly, but here I cannot. So it has this 32 on the end. Let's see. If we change this to 8, let's see if that's just a coincidence. Yeah, it was just a coincidence. So let's look up. It looks as if the salt and number of rounds are stored with a hash. Follow the link in the answer to get an explanation about the hash format. Oh. Oh. Wow, did I just miss that in the beginning here? So here's the number of rounds. So let's try like 20. See if that explodes the computer. Probably won't even generate it. Yeah, you know what? Well, it did 16. So let's try 20. I think it was saying every round takes double the amount of time. So you know what? Let's actually just try 17. So in 17 rounds it took that long. Let's try doing it with 18 rounds. And so it's going to take that long every time someone tries to log in. So you have to question, is that worth the extra security when you're implementing this? If you're handling people's financial information, I don't think you can have too much security unless it's just unusable. So that took a while. Let's go and bump it up quite a bit and see how long it takes. 24. See if we can break the Replit virtual machine here. I wonder if that utilizes the client. Does Replit use my resources to run the code? I'll have to look into that later. Okay, it's still cranking on. So I probably gave it too many rounds. No one's going to wait this long to log in. But no one will ever brute force this with a computer this powerful. Whatever this is drawing the resources from to run this. It would be interesting if it was using my resources, but I don't think from the browser it can do that. All right, anyway, we went over the assignment. We looked at how to implement hashing passwords, which you should know how to do it the way I showed you. You should know why we do it. You should You should never do anything worse than the way I showed you here, because it's out of date if it's worse than this. If you need to constantly be looking the next time you do a project that uses passwords, look at what the best practices, or the state-of-the-art hashing, or whatever they use for security to protect passwords in a database or wherever they're stored, and use that. You can't be complicit with security on the web like so many people are. Because as computers become more powerful, I don't know, 5 years down the line, 10 years down the line, this will provide probably no security whatsoever with how powerful computers will be. We'll have to continue. It's like a war. They figure out that we can break it. You have to figure out something more complicated, back and forth and back and forth. So you have to constantly be on top of the security aspect of it, just like every other aspect of it. All right, so I think that's enough of me talking. Good luck on the project. Make sure you do start on it ASAP. Don't put it off. You can do it a little bit at a time, or however you want to do it. I'm so nervous for you guys. I want to make sure that I covered everything. Okay. Yeah, all this is doing is storing the password as a hash. Okay. All right, you saw what I changed in here. Well, I'll go ahead and post the repository for this from my GitHub so that you can clone it and have a working version with this hashing that you can look at. So we gotta update that. So we'll do, whoops, not in the database. All right, so we'll do git add dot git commit -m added password hashing with salt. Okay, Then we'll get push, so that's available on my remote repository, which is public, and you guys can just download if you want to see any of the code. Remember, if you download it, what I would recommend is cloning it to your machine, and you have to, what am I thinking? Oh, you'll have to go to the Studio 9 branch, right, to see the proper code. I'll put all that in the directions. I really want to make sure that you're ready for this. I can't remember if I had to update this or not. Nope. Okay. Git push. Yeah, I add a symbol. Yep. Okay. So now that's on the remote repository. So I'll go ahead and maybe I can just provide the link directly to that inside of there. Where do I have the class pulled up? Not in here. I'm going to go ahead and close this so I don't keep going. I was thinking about showing you a brute forcer for this Decrypt salter, just to show you how inefficient it would be to brute force it with this machine anyway, by itself. Okay. Oh, here it is. So in blogs, I'll go ahead and put it in here. Okay. You can reference my flip list 9 or my flip list studio 9 for a working example. Alright, and then profile link for you. I think we've boiled down to about 2 people that are still actually able to keep up in this class. So even in spite of the virtual modality. So I'm going to find my flip list. Let's take a look at the Studio 9 branch. Okay, then we can check the code here. Let's see if it can go directly to Studio 9. Guess you have to download the entire repository, as far as I'm aware. Okay. Clone the following. And don't forget to switch to the Studio branch. Alright, so there's that. Okay. Good luck, and I'm looking forward to seeing what you guys can do with this. And I'll see you later. Let me know if you need anything through email or set up a meeting with me. Have a good night.